All right, welcome back. To some of you guys, it might be a day or so. To me, it's only been a few minutes. Again, I'm running out of jokes. Let's begin. So for this lesson, 8.1.3, we're going to be figuring out the stretch factor for polynomials. And if you remember stretch factors from all the other functions that we visited in this class, then you'll know that we need a third point to find what a is on the front. And you would be right. You would be right to think that. But I'm getting ahead of myself. So let's begin, and if you don't know what I'm talking about, we'll figure it out together as we do this lesson. So relax. Let's do the first one. Write a reasonable equation for the polynomial function below. How would you check the accuracy of your equation without using a graphing calculator? Was your equation accurate? So, let's start with what we know. What we know from the last two lessons. We know that it's gonna be, we know that it goes up and down, so we know it's a negative leading coefficient, and it has degree 3. Right, that's what we know. We know that it has a double root in -2. We also know it has another root at 1. So we can write those out. It would be, what did I use? I'm going to use f of x. F of x equals x plus 2 squared times x minus 1. Right? Negative and degree 3. Well, we need a negative to put out front because we know it's negative. But here's the thing. Can we figure out what goes in front of it? Do we know that this will give you that? Well, obviously the question is leading you to say no. No. Your equation was not accurate because we don't know what goes out in front. So I'm not going to worry about it and helping you solve that right now, because if you guys go on Desmos, you'll know that it won't hit 0.8. It's not going to hit that, but we can use that to find the scale factor in front of the function. But before I get ahead of myself, we can reasonably answer no. Was my equation accurate? No. All right, let's look at A-40. What is the difference between the graphs of the functions? Well, the second one has a scale factor of 3. Second function has a, scale factor of 3. That's it. We're good to go. Now it says write the equation of this polynomial function. The graph passes through the point 116. So now we're given a point. Can we use that to find the a? Do you guys remember how to solve for a from the I don't remember which chapter we did that on, but do you remember from previous chapters? I'm hoping you guys remember that. It's a really important chapter. Hopefully you guys had fun with me when we were doing that. But let's do this one. So what do we know? It goes up and up. It's even, right? Because they're both going up. Even. What's the degree? 1, 2, 3, 4. So it's degree 4. Even. What's the leading coefficient? Positive. Positive. Well, somebody's car is going off. Well, thank God that didn't last long. All right. Let's do our preliminary equation. We'll just write a for scale factor like we've done before. So let's do p of x equals a times x plus what? The first one, first root, 3, times x plus second root is, well, -3. But what's the second one? Second one is -1, x plus 1. And and there's a double root at 2. X minus 2 squared. So we know that we have 1 and 16. We can just plug that in. 16 equals a times 1 plus 3 times 1 plus 1 times 1 minus 2 squared. What do we get when we multiply them all up? Well, I'm going to give you a hint. 8. 8a. A equals 2 when we divide it by, and our new equation is going to be p of x equals 2 times x plus 3 times x plus 1 times x minus 2 squared. All right, so a will also give you a positive or negative coefficient. You don't need to put negative a if it has a negative, because that's just going to mess up with your calculations. I'm just writing positive because to fact check when I find a. Yeah, a equals 2. But if it's negative, I'm just going to leave it as a. I don't need to do anything to a. I don't need to find whether it's positive or negative. I only needed to do that if I didn't have to find the a. But I do need to find the a now. So I don't need to worry about that when I'm doing that. A stays a. There's no negative a. Just want to make that absolutely clear. And if we keep looking through and we check our work, is it degree 4? Yes, it is. X squared times x cubed times x to the 4th. So on and so forth. If you are confused, watch my previous lessons. I hope not. I hope I did a good job. All right, let's do 8-43a. So we're going to look at this. We're going to look at these graphs, and we're going to do the same thing that we did for 8-41. But now we're just given a graph. All right? I don't need to worry about anything except for the roots. I have 2 double roots. I know that already. So let's write our preliminary equation with a, and then solve for a. So I don't want to use p. Let's use s. S of x equals x plus, let's go 1, 2, so plus 2 squared times 1, it goes 1, it hits 1, x minus 1 squared. Oh, and the a. Even I will forget the a. So what point do I know for sure on here? I'm going to say the y-intercept because it's at 0. Y-intercept is at 0. 1, 2, 3. 0, 3. I can say, well, I mean, you can never be too sure. It might be 2.9 something, but I'm just going to, you know, for this problem, I'm not going to be a stickler and be like, well, you know, you should have gone out a magnifying glass and figured out exactly how far it was down from the x-axis. No, I'm not going to do that to you guys. So let's go. 3 equals a, 0 plus 2 squared, 0 minus 1 squared. What do I get when I multiply these together? First, I got a 2 squared, 4. 4 times 1, 4. So I get 3 equals, 0, negative 3. Yeah, it goes down 3. Whoops. We all make mistakes, even though I have the answer. So this is embarrassing. Negative 3, yeah. So it'd be 4a. We divide 4 on both sides. We get negative 3 over 4. Plug it back in, and we will get our function. Remember that quadratic equation with the water hose problems? These are the exact same things on, you know, trying to find a. We already have, we can find our other point on the graph. It has to be on the graph. I can stress this enough. You can't make it up. It has to be on the graph to find a. Like those water hose problems. And then x minus 1 squared. There we go. That's it. That's all we do. Let's do B. Unless you've done it. Unless you went ahead and already did it. In that case, you're cheating. I'm kidding. Told you guys you could do that. I don't know if you guys understand my humor. That's what I'm saying. I'm kidding. It's pretty dry and I act kind of serious. But, yeah. That's me being sarcastic. And my voice is dying. So, there's that. So, let's do this one. It has a point at the y-intercept. So obviously it wants us to use the y-intercept. So let's find that right now. Y-intercept 0, 16. I'm not going to count them all in front of you. I'm pretty sure you guys don't want me to do this. All right, we have a double root here and we have a single root there. So by the looks of it, it's also a 3rd degree polynomial. And it is going up and then down. So it should have a negative leading coefficient. But we'll find that out once we solve for a. So let's begin. I'm going to use q this time. Just be a little weird, be a little out there. Well, some of you guys might say, I'm already out there. You guys aren't. That's very true. I am very comfortable speaking to myself. So this one, the first root is x plus 2. Because it goes back, negative 2. And it touches, it doesn't cross, so it's squared. It's a double root. Then it goes 2 on the right-hand side too, but it does cross, so it's just x plus 2. No square. We're good to go. So we're going to use 0, 16 to solve for a. 16 equals a times 0 plus 2 squared times 0 plus 2. And what do you get when you multiply all of these together? 2 squared 4. 4 times 2 is 8. So 16 equals... Oh, it's minus 2. Why do I keep doing this? Why do I keep doing this? Some of you guys probably were screaming through the camera. Well, today's your lucky day. I guess I did hear you guys scream. I made a mistake. You made a mistake. Fix it. Yeah, you guys were right. Negative 8a. A equals negative 2 when you divide by negative a on both sides. So what is our new equation? Q of x, or function. Q of x equals negative 2 times x plus 2 squared times x minus 2. Yes, I did it right this time. I don't know if that counts for much, but hopefully you'll find it in your heart to forgive me. All right, let's continue. Let's do the back page. All right, let me set up. So, the question is asking, write a polynomial equation for a function with a graph that bounces off the x-axis. What does that mean, bounces off? Well, you guys are right. It's just going across the x-axis. So you know it's going to be a double root at negative 1, 0. And then it crosses at 4, 0. So you know it's going to be a single root at 4, 0. And goes through the points negative 2, negative 18. So what do we need to find? Yep, you got it. We're going to need to find a. Jesus. All right. So I'm going to use v of x equals, let's do the double root first. A times x plus 1 squared, because it's negative 1, 0, times x minus 4, because it's positive 4. Yeah, that's more for me than it is for you guys, because I made that mistake once. So negative 18 equals a. Do we need to know the graph or anything? No, because a is going to give it to us. It's going to tell us whether the leading coefficient is positive or negative. We don't need to graph it. Well, we don't even know what the graph is. So we are good to go. So negative 2 plus 1 squared times negative 2 minus 4. And we know that it does cross through that point. We can't use just a random point. It has to go through the graph. All right, negative 18 equals a. And if we do it, negative 2 plus 1, negative 1, times negative 1 squared is just 1, times negative 6. So we get negative 6. I know some of you guys might get a little OCD, negative 6a. We divided both by negative 6, and we get... Well, I did it wrong on my paper. We get 3, not 2. Math, it's hard. Just kidding. V of x equals 3 times x plus 1 squared times x minus 4. There we go. We found the function. All right, let's do the last one. What information about the graph of a polynomial function is necessary to determine exactly one correct equation? Well, let's start with the beginning. We need the roots of the function. So we're going to need, we can call them real roots, we can call them x-intercepts, your choice. I'm going to call them real roots. I need real roots. And what about those real roots do we need? Need to know whether they... Need to know if a function, hopefully you guys have seen it. What does it need? It needs to know if a function bounces off the x-axis or crosses the x-axis. Or crosses the x-axis. I should have been reading that out loud. All right, put a bullet point. What is another thing that we need? And a random point that crosses through the function, but isn't a real root. Hopefully you guys noticed that it can't be a real root, because if you plug in a real root, you're just going to get 0. Makes no sense. So with this information, I wish I could do it in person so we can bounce off of each other. But is this the amount of information you need to determine exactly one correct equation to solve for A, to figure everything out? I would say so, because you don't need a y-intercept, and a y-intercept would be covered by this condition. So there it is. If you have any questions, let me know, and I will answer your questions the next time we meet online. So thank you, and I will see you in 8.2.